Hello and welcome. Today I'm going to show you how to run the simple cloud model lots of times so you can do the factorial method on the data. So in order to do that, we look at runs define. So this is a Python script which is inside the ice precipitation modeling and Python folders. So just open up runs defined. And you can see here there are 6 different factors, 1, 2, 3, 4, 5, 6 that we're looking at. And we're setting 2 separate values for each of these. So this one is the cloud top temperature. So we've got a high and a low. That's in degrees Kelvin. Here we have 2 different definitions of aerosol. And that's just pointing to 2 different files, here and here. Here we have HM flag set to true and also set to false. Now that's the Hallett-Mossop process, which is a process where if you have pre-existing ice, then you can get more ice. It's known as a secondary ice process. So look up Hallett-Mossop process, HM flag. Here, this is the warm rain flag. So this is either set to true or false. So when it's set to true, it allows the production of rain by collision and coalescence of smaller droplets. When it's set to false, it doesn't. RM flag, that's the rhyming flag. So this is where liquid droplets can collect onto existing ice crystals. That's known as rhyming, if that's set to true. And if it's set to false, that's not allowed to occur. And also ice flag. This just means if ice flag is set to true, that means that ice is a possibility in the model. If it's set to false, ice is not a possibility in the model. And columns, this is for the output later. So this is just saying that the first one is related to temperature. The second one is related to aerosol here. This is Hallett-Mossop, this is warm rain, this is rhyming, and this is ice. You should also set the output directory to be any directory on your computer that you can write to. And the locations are separated by forward slashes there. That's important too. Okay, so when that's done, all we need to do is open up batch runs and we need to click play to run that script. You can see it starting at run number 00. It should do 64 runs in total because if we go back to runs define, doing each of these runs is 2 to the power 6 runs, which is 64. So we need to wait until that's finished now before we do the analysis. So that'll take a short while. So now we can see that we've got our 64 simulations with the simple cloud model. We want to analyze those results. So for that, we go and open up factorial method, and we just run that by clicking on the play button here. And just wait a short while. It looks like the factorial method has finished now, and it's printed these numbers to the screen. So the way to read this is first to look at the effect of x, y, z. That's these 6 numbers here in this list. These are the effects of each of the factors. The first number is the effect of reducing the temperature of cloud top. The second number is the effect of choosing different aerosol inputs. Third number is the effect of the Hallett-Mossop process. Fourth number is the effect of warm rain. Fifth number is the effect of rhyming, and sixth number is the effect of having the ice phase switched from on to off. Okay, so in terms of the largest effects, we can see that actually reducing the temperature of cloud top, in this case, has the biggest effect. It's got a plus 11 effect on the precipitation on the ground. So because this is positive, it means that reducing the temperature of the cloud top increases the precipitation. The next largest effect in terms of largest absolute number, is the is the fourth effect, which is warm rain. So that has a -10 effect here. That's the effect of switching warm rain from on to off. So that means that has a negative effect. So it actually reduces the precipitation. And you can see the others are fairly small in comparison to these effects. So changing the aerosol has a positive effect in this case, whereas switching off the ice phase has a negative effect, which kind of makes sense. So that's the simple effects of X, Y, and Z. And then we have these more complicated effects, which are interaction terms. So this is like a table now, and the columns here, the interactions between temperature, aerosol, Hallett-Mossett, warm rain, rhyming, and ice, and the columns are the same factors. So 0 here is temperature, 1 is aerosol, and so on. You can see this table is symmetric. It has nans down the middle because you can't look at the interaction between temperature and temperature. But one way to interpret this is to say, look at the effect of the interaction between temperature, which is this first row here, and ice, switching ice from on to off. So what we see is the effect of switching from temperature from high to low has an interaction with the ice phase, and that makes sense because if you have a cloud top with a lower temperature, you might expect the ice phase to have a bigger effect when the temperature is lower. But switching off the ice phase has a negative effect in that case because you have less ice in the cloud, and ice can lead to precipitation. So I'm not going to talk through what all of these numbers mean. I think that's for you to do in your project, and you'll have to read the paper on factorial method to do that. But nevertheless, that's a quick overview in how to run and analyze these results. Okay, hope you found that useful. Don't forget to hit a like on the channel and subscribe if you found that useful. Thank you.